Welcome back. In this tutorial we will study about critical section problem. The process is executing concurrently in the operating system. They can be independent processes or they can be cooperating processes. So what is an independent process? The independent process does not share data with any other process. It cannot affect or be affected by the other processes executing in the system. Whereas a cooperating process shares data with other process. It can affect or be affected by the other processes executing in the system. Cooperating processes share data with each other. Concurrent access to shared data may result in data inconsistency. As we saw in previous tutorial race condition, that when two cooperating processes access a shared data concurrently, then it resulted in race condition. We need to ensure a way that only one process at a time can access the shared data. We need to synchronize the processes in some way. We need to synchronize the processes so that only one process at a time can access the shared data. We need to synchronize only the cooperating processes. We don't need to synchronize the independent processes because only cooperating processes share data. So in this tutorial we will study about critical section problem. Its solution can be used to ensure consistency of shared data. Suppose there are n processes, P1, P2, P3 and so on up to Pn, and each process has a code of segment called critical section. This code of segment of the process accesses the shared data, right? So when a process is executing in its critical section, then it accesses the shared data, and we want that only one process at a time can access the shared data. So what happens? Only one process at a time is allowed to execute in its critical section. In critical section, a process may be changing common variables, updating a table, or writing a file, and so on. No two processes are executing in their critical section at the same time. So what is a critical section problem? This critical section problem, we have to design a protocol that the processes can use to cooperate. And each process must request permission to enter its critical section. The section of code implementing this request is the entry section. The critical section may be followed by exit section, and the remaining code is the remainder section. The general structure of the process is like this. There is an entry section. In this section, the process requests the permission to enter in its critical section, and the critical section may be followed by exit section. A solution to the critical section problem must satisfy the following three requirements. First is mutual exclusion. It means if a process P is executing in its critical section, then no other processes can be executing in their critical sections. Second is progress. If no process is currently in its critical section and there are few processes which wish to enter in their critical section, then only those processes which are currently not in their remainder section can participate in deciding who will enter the critical section next. Third is bounded waiting. There exists a bound or limit on the number of times that other processes are allowed to enter their critical sections after a process has made a request to enter its critical section and before that request is granted.